Hello, everybody, and a very warm welcome to you all on this Wednesday afternoon. My name's Kyron. I'm working in our technical sales department, and today I have the pleasure of bringing to you some of the products that you see in front of me. So we're going to be talking roof anchors and how we can fix our system to flat roofs, mostly in situations where perhaps you have a higher roof slope or you have no load reserves on the building. Join with me. I have another technical expert. I would say, Vlado.
Yeah.
Welcome today. What will you be presenting?
Yeah, we will talk about anchors. I will show such small presentation we prepared for you. Today not all the components, but also short videos, so short presentation. Yeah, and also we will show you how to calculate anchors in base, what are there to take care about, and so on and so on. Maybe some rules about for today's webinar.
Yeah, absolutely. So maybe, or would you like to go prepare for the
Yeah,
presentation?
exactly. Yeah.
And I'll just run through some housekeeping for everyone. So uh, you will receive an email tomorrow with a recording of this webinar and any files or documents that we're presenting. So don't get too concerned if you do have to leave at any moment. If you do have any questions today, we would really like to hear them. We appreciate them being put in the Q&A section of the Zoom function. So down here somewhere, there will be a Q&A button. This way we can answer those questions directly. If you can't hear us, for example, or if the lights go out, feel free to throw that one in the chat because we can react quite quickly. But specific questions and then specific answers are much easier followed in the Q&A section. Uh, I think that's probably about it. Oh, we have had a survey. We will have a survey. Okay, we have no survey today, so lucky you as the audience. Um, well, I'll pass back over to Vlado and we'll kick things off.
Yeah. So let's start with our presentation. Yeah. So we talk today about ballast and anchors. What is the idea of our today's webinar is to make you no longer afraid about installing anchors because it's not so complicated to install. You don't have to be afraid about roof penetration. Yeah, there's also a lot of advantages of using anchors instead of ballast, but also in combination with ballast. So this is our agenda for today, and we will start with this common topic: security aspects. Yeah, your concerns maybe. Yeah, roof leaks or poor ceiling. Yeah, this is our answers to it. So you have to understand that if you install an anchor, you will weld it, and the installation at the end, so on the top, yeah, it will be like the same as your foil, which is already installed on your roof, maybe because anchor will be completely welded. There will be no space for water to come underneath of the anchor, so your roof will still complete watertight. Next one. Thermal insulation, thermal bridges. Yeah, it's also an important point. So people are afraid. So if you put the screws through your insulation, you will like lost a lot of warmth. Yeah, during winter time. So and our answer to it that these penetrations are so small that there will be probably no effect on thermal insulation at all. Expensive and difficult to install. Also, yeah, maybe cost factor is maybe the most important factor, yeah, because the also cost for the anchors. You will also need an additional component for our flat roof systems, our FixPro system. We will show you later, yeah. But there are also some advantages, yeah, because if you have a roof where you cannot put a lot of ballast, yeah, or no ballast at all, so you can install the anchors. Yeah, so also for roofs with high inclination. So maybe on this point, it's very important to say that for our systems, for our flat roof systems, we say only the roofs until 3 degree. Uh, only so on roofs until 3 degree, you can install our systems with ballast only, with no anchoring. And starting with 3 degree, you have to install anchors. Yeah, and so for high inclination, you always will need to install anchors in our systems. Ballast savings, yeah, it's maybe the most important point. Yeah, you installing anchors, you can so anchor in our systems has two functions. First of one to prevent sliding of your system, and second is to replace ballast. So you will need less ballast, but instead of the ballast, you will install anchors on your roof. Before we start with this installation video, Karen will show you the anchors. How do they look in real? Yeah, what are the differences? Maybe some special features of the anchors.
Okay, thank you, Vlado. So one thing we'd like to point out here as well, these products that we'll be displaying in front of us, these are not products that we sell. So we will be, all of our products fixed to some form of roof anchor, and we can do that in slightly different ways, but the reason for this is roof fixing is often a quite bit more specialized topic than what we would like to get into, and so we leave that to the experts effectively. The companies that produce these roof anchors are also doing things like fall protection, installing existing build or structures on top of the buildings as well. So it's a little bit of a different industry that we are now the interface with. So we're not we don't have any affiliation with any specific company. We will be showing a couple of products today from different regions. There are many other ones out there as well. And effectively, if you have a bolt on it, we can fix to it. So if you have a different roof anchor, then that's suitable as well. And we'll show you how to do that in base as well. So we'll jump to maybe a bit more, and this is one of them. So this is from CV Lumberg or CW Lumberg, which is more common in, I think it's a Swedish company, but also very common in Poland and some of the other countries in this direction. And so this is quite a large square plate. You have a bolt that comes in different sizes. An important point actually though is this bolt size. So regardless of the product that we're talking about, this needs to be a certain length. For the CV Lumberg plate, it comes in multiple, so 35 millimeters, 50 millimeters, 75 and 100. It needs to be at least 50 millimeters long. Right? So this is going to allow us to fix to it. The general idea is then we're going to screw into it at number of points. This is the CV Lumberg. Usually this comes with 4 screws, and they will fix into the board, decking, whatever is underneath. So depending on the decking as well, you might get different screws. Just for an example, this is one of the screws we might, a screw we might use. We just lost video. There we go. An insulated membrane where you want to screw into the under construction, usually a trapezoidal sheeting. But you could also have wood screws that just fix into the top layer. This idea of fixing is common, although a little bit different in different places. So for example, a different hook that is used is one with the seeker anchor. This comes with sometimes 2 or 4 screws. Generally we're doing our calculation with 4, but the idea is pretty similar. You're going to drill or put a screw through here. An important point with the seeker anchor is it actually comes in 2 parts. So the part over the top screws on. I'm hoping the whole thing is screwing here. And then this is going to be the membrane that seals the screws and ensures that it's watertight. The CV Lumberg has different membrane sort of covers or water sealing covers, and we'll show that in a little bit of video later on.
That's yeah.
And it comes in 3 parts actually.
Exactly. Yeah, it comes in 3 parts. So it's a leveling set from Sika. You just take care that if you're ordering anchors from Sika, you also order this leveling set.
Yeah, and this just allows you to have different heights. So as you lower this, you're going to screw it into a different height, and therefore allows you to get a higher bolt. And then if you have any unevenness in the roof, then you are able to compensate for that with this height here. Another product that we have, and this also kind of shows how the membrane system works, is the Solmont. So Solmont's a product in Germany that's quite common. Again, we're screwing in the specified holes, and here some form of plate will go over, or some form of membrane will go over top, and this will be either heat welded or cold welded or rolled on, and we'll discuss that in a little bit more detail after that. For all of the products that we have here and all of the concepts, the next step is very similar, or I would say even the same. We will place our climber set. Whether you have an M10 or an M12 bolt, it doesn't really matter as long as you know it's an M10 or M12, because then we can give you the right components. It's just then going to screw on and fix to our FixPro set. And we'll show that in a video a little bit later, but I just want to give you the idea that regardless of sort of what bolt you have, you're then going to put our climber set and our adapter plate, which are products that we use for our single rail system, and are sort of very well known products in the K2 range. Before I pass back to Vlado, so just like there's a couple of other products that you could also fix to that I know of. So in the UK, Nicholson and the IFPs are very common, and the team there use them regularly. VE Land or as in VE Land from the Nordic countries as well. That's got a bit of a different profile. It's more of a C channel. That's also something we can fix to, but a little bit different to this. And effectively, if you have a roof anchor product or company or a way to fix something to the roof, we can then put our system to that. And what we'll show now is a video a bit about how some of these are installed and how they're fixed to the K2 product range. So, Lado, I'll pass back to you.
Yep. Thank you, Karen. So let us show this our small video, especially recorded for today's webinar. So you can see the guy like screwing this anchor to the trapezoidal sheet. Yeah, by 4 screws in the corners. Yeah, so through the insulation with the very long screws. Now it's very important to clean the foil before you weld. How we called it? Manжеты? No, this part. How we called it? Okay. Yeah, the ceiling cover. Yeah, exactly.
Yeah.
This part of the foil so it's important. This is like the same foil if you don't have it, or if you want to use one which is for sure is compatible with your foil. You can just cut a piece of the foil you have already on your roof and installed it, so weld it in the same way. So it's you will have for sure a compatible part of the foil on your roof. And now we see this welding. This is hot welding, so with hot air. Yeah, important to say that it's like it's done by a professional. So don't try to do it yourself. You will need a professional roofer for this. Yeah. Now it's cleaning again, so you will get like very good connection between the foils, between the foil on your roof and this part of the foil which will be welded on it. Uh, you see it will be welded on each point where water could get underneath of the anchor. You can see it will be welded, so it's like completely attached. So there is no possibility for the water to come through. Uh, So now the anchor is completely installed, I believe. Maybe some points. So now our colleagues are showing how to install FixPro. So this is our FixPro. So you install the nut, yeah, mount it on the anchor. Then you will put FixPro between two rails. Yeah, you can see it. Yeah, it's like installed on both rails. Yeah, install adapter plate, climber, and the second nut. Yeah. Now colleagues fastening. Yeah. This one's again the same, but you can see it in detail. Yeah. So again, adapter plate, climber, two nuts. Yeah. FixPro has the same channel as our single rails. So you could, so this is the same climb, the same adapter plate you can also use with our single rail. Yeah, in the idea is the same. Yeah. So now it's on correct height. Yeah. So this thread rods there to put the FixPro on the correct height. That's everything correct, and you just attach it to the rail by using our MK2 nut with a screw, usual one, very simple. Uh, Now it's installed. Uh, So let us proceed with another video probably. So this is also a short video showing cold welding. Yeah. In this case, these two pieces of foil are welded not with hot air, but with some chemicals. Yeah, maybe we can just go through it. Yeah, yeah, maybe let's go to the important for us parts. Yeah, wearing everything. Yeah, and now he's just putting this chemicals between the foils. Uh, Also removing the rest of the chemicals right away. Come on, let's do it. Yeah, so it's done in this way. Um, so, but our anchors not necessarily must be screwed in. Um, there are some countries where you don't have to screw the anchors in, but you also can just weld them. Please check your local regulation. So I know that in most of European countries it's also allowed just to weld them. So this is a sample video from CV Lundberg how to weld an anchor on bitumen roof. So and you will see that here no screws will be needed, will will be installed. So you just weld a bit bitumen underneath of the anchor, then you install anchor. It's a threaded screw, and then you put on it another piece of bitumen. Now everything will be welded, so there is also no possibility for water to come inside, come underneath of this piece of bitumen. Uh, Now everything is completely sealed, and here install our FixPro. Yeah. So let's go back to the presentation probably. What do we have here? Uh, this is our FixPro. Yeah, these are components which are used with our FixPro. So you will find here our usual MK2 nut, screws, and FixPro. Here are some of our rules, yeah, for ballast or for anchors installation. So all roofs until 3 degree you can install ballast only, but you can also install combination ballast and anchors or only anchors. And starting with 3 degree, you will have to install anchors. For roofs from 3 till 5 degree, you can install combination ballast and anchors or only anchors. And for roofs uh, with inclination more than 5 degree, you will have to install only anchors because ballast will slide down from the system, so you will need like additional uh, feature to fasten the ballast, not only use your system. And this is the reason we say so for installations from 5 degree, you are yeah, so and we understand flat roofs in general till maximum of 10-degree. If you have a bitumen roof, for example, with 15-degree or 20-degree, we have also another solution as our splice foot. And currently we have also a different solution, single rail AFP. Probably I will show you later how it looks like. So these are some pictures for installation of FixPro. Yeah, how to install it. Here's again our climber. Yeah, just coming inside of the FixPro. Here's one important roof. Yeah, that's this is the distance between anchor and the rail must be more than 700 millimeters. In our base report, you will not find exact distance between the anchors because we only say that your anchor must be placed below one specific model, and that's also you can move it a bit to the left, to the right, because you will also need to screw the screws into the crest of the trapezoidal sheet underneath of the insulation. And this is the reason we do not write exact distance between the anchors. Um, Here we're try to explain you how to install the anchor. So here's usual structure of a foil roof. You will have your membrane. Underneath of it, you will have insulation, and under insulation, you will have trapezoidal sheet probably. Yeah, and installing anchors, you must install the anchors into this high crest of the trapezoidal sheet. Yeah, it's very important because here you will have no connection to the trapezoidal sheet, so your anchor will be installed completely wrong. Oh, I believe it's all. Um,
So we could just show
yeah,
one point of
exactly.
the
Yeah, and
um, important point as well that we've noted as well. One important point that we should bring up as well before we get into the base design. So we showed a small presentation or a small picture of how the FixPro Set is installed, and you have a bit of an idea here of how it's being set up, where the rails are running along here. Our modules are going to sit down so angling towards you. Normally, or generally speaking, with all of the anchors except the seeker anchor, it's going to be installed something like this, where the anchor, and then we have a nut followed by our adapter plate, climber, and then this will fix into our FixPro Set. And it's just going to sit into here. With the seeker anchor, however, the seeker anchor is a lot higher in terms of the material underneath. So using this product, there is a little bit of work that has to be done on it. You can buy the product; it just has to be effectively flipped on site, and the ends will need to be moved. And I'll just spin this one around. It's kind of to show you. And so instead of installing the adapter and the climber on top of each other, we're going to install the climber into the rail, and then the adapter sort of on top of that, and then tightening from the same way. So the idea is, I'm sorry if that's a bit loud, but you can see it now tightening up. The idea is the same. It's just sort of flipped. And if you notice, I have not done this on both ends, but this is what you need to do. Klaus, maybe if we could just get a close up on this one. You would need to undo this bolt in here, and then pull out the end, and then just flip it 180, and then redo it, and then it's going to work exactly as it would with the normal setup. So it's just something to be aware if you're using the seeker anchor. All of the products are the same. It's just a little bit of work on site to solve that problem. So I think we then probably jump into the base. Or is there anything else we could add? Ah, yep.
yep. Maybe we can also share the screen. Yeah, because we have not only our well-known Dome solutions, yeah, but we have also some different solutions we install only on anchors without ballast. Yeah, for example, this one is Dome lifted LS. Maybe I will make this picture a bit bigger. Yeah, the idea is that the system is installed only on anchors without well-known fit here. Yeah, So this is done if you have, for example, very soft insulation where you cannot put any loads on it. So you will install the system on anchors. Yeah, we can also calculate the loads on your insulation, pressure on your insulation to provide you like a safe solution where you will know that your insulation will not be damaged by the system. So this one is lifted, yeah, is with our usual 10 degree. It's like our classic, our usual LS systems, but installed on anchors. And here we use instead of our known basic rail, we use here single rail 36 or strongest single rail 50. Another solution we have is our single rail EFP. Um, what is the difference? Here we install the model's roof parallel, also on anchors. Here we use the same single rail 36 or 50 and installed on anchors. And this solution you can also use for roof pitch until 35 degree. Yeah, here you see it from 5 till 35. Make it bigger. Sorry. Yeah, thank you, Klaus. So here for roof pitch from 5 till 35 degree, you can also install this solution. Yeah, roof parallel solution, because if you have a roof with 10 degree, there's no reason to install elevated system. You can install a roof parallel system on it. Karen, maybe we have some questions which we want to answer live.
Uh, no, we don't.
No, we don't. Okay. Then I will proceed with base calculation. Oh, let me find it. Gateways here. Yeah. So here we prepared already one roof. We will not today. We will not go through all these details, how to design a roof, how to create it, how to find out your terrain category, and so on and so on. We will start already with one roof. Well, this is our roof with classic system. Yeah, our didn't classic less didn't the same classic system, usual one, not less. Yeah, and here's the calculation of the ballast. You will see that here you will need a lot of ballast. Yeah, on some points you will also use not only speed porters but also porters. Yeah, on these spots. And here we have a roof with only 1 degree, so that means that you can install anchors, but you must not in this case. And how to add anchors to your calculation, you can select this option. Yeah, use anchors. And here you will see right away that here is option to select an anchor you want to use, because as Karen said, we do not sell anchors. We are not interested to put you to one of the anchor manufacturers. Yeah, it's only up to you. Yeah. Here you will see Solomon ABC. Don't be afraid about this name. ABC means a special certification for Germany. So you can just use usual Solomon. Civilumbic welded or screwed. Yeah, because at the moment uh, only welded anchors we have in our base is Civilunberg, and here you will see Sika anchor. Yeah, Sika anchor we have two options. This one you will see it's like for bitumen, and if we change our roof material to foil, you will see that now we have here Sika anchor for PVC membrane. Yeah, here are some values for your anchors. So if you don't want or don't want to use one of these anchors and want to use a different one, you can just put here the values of your anchor. Uh, put here connection. It's also very important. What is the threaded rod? Threaded rod on the top of your anchor, is it M12 or M10? Yeah. Um, for these anchors, we know already. So this is correct connection. For example, Sika anchors are using M12, and Ludwig anchors are using M10 connection. Yeah? And here are the values. So you can see that the values are different for different anchors. Yeah, for example, this one and this one, you will see that the values are different. So what are these values? The values we get from the anchor manufacturer. They are saying to us what is the which loads the anchor can withstand, how we calculate it. We have our ballast calculation coming from our wind channel tests. Yeah, and this ballast we just transfer to the loads, and in this way we know how much how many anchors are to install for a specific model field. What exactly? This one. Uh, there are two options to install anchors. Yeah, for roof from 1 to 5 degree. We will say two options because we can combine ballast and anchors. So here uh, the anchors are used only to prevent sliding of the system. So you will see that here, if I select the anchors, yeah, what is our ballast? 12 tones. So if we deselect the anchors, you will see that the ballast is just a bit more, yeah, because the anchors are used mainly to prevent sliding and not against lifting of the system. But if we'll select here all, in this case, anchors will be used for both against sliding and against lifting. So you will have no ballast at all here, yeah, but you will have much more anchors here. Um, so if you have a roof with 4 degree, for example, you will see that it's already gray, so you cannot deselect anchors because they must be installed. Yeah, you can just decide if you want to combine ballast and anchors or install only anchors. Yeah, please come on. And having roof pitch more than 5 degree, for example 6 degree, you will have only one option. Yeah, use anchors and replace uh, ballast completely. Yeah, you cannot combine anchors and ballast on the roof. You can only install anchors. Um, so let maybe the anchor system. Yeah, let us copy the roof. Yeah, let me rename it. Yeah, it's if you will use anchors, you will always see this nice message that anchors are not passed, are not a part of our products. Yeah, copy it again. So let me create a short version of our report. Show you only maybe show assembly plan as well. So yeah, so this is our report. First part I want to show you, it's as a loads on the roof. So you can see here, installing ballast on this roof, you will have like a lot of ballast. Yeah. Okay, this is roof. Yeah. Sweet. No, I will just this roof. Uh, uh, Please just not saved the changes. Do it again. So on the first roof, we want to use no anchors, but only ballast. Yeah, let's create this report again. So this is results for our roof without anchors. Yeah, and you can see here like great loads on your roof, on your isolation. Yeah, it's up to yeah, 32 kilo per quadrat meter, per square meter. So it's like a lot of loads. Not all roofs can withhold such loads, are able to withstand these loads, especially older roofs. And let us compare it with roof with anchors. Our results. You will see that in static anchors you will have only 11 kilo per square meter under model blocks. Um, Here, coming back to assembly parts of the system. So, as I said, you will see here only a model under which this anchor to be installed. You have here no exact distance between the anchors, but only a model where you have to place the anchor. And usually it's the corners of each model block. Usually you have to place the anchors, yeah, to prevent the wind to go underneath of the system, lifting it. Uh, or maybe, yeah, maybe it's Karen, do you want to show something else? Because I believe.
Yet I was just measuring, but we do have some questions that maybe we could go
Oh,
through.
yeah, let us do it.
So there was one question about the coefficient of friction, and how that will impact in terms of the anchors. And so I thought maybe you could jump back to the roof page, and we could just maybe briefly talk about what
Yeah,
this represents, and then also
exactly.
talk
So,
about, yeah,
friction coefficient. Oh, it's everything is in German, fortunately.
that'll
Uh,
stay in German, I think, regardless.
no, we can change it. Switch the language.
Yeah, if you click the three dots on the right, make that the, um, yeah.
So let us go again. Friction coefficient. Here, if you will click on this question mark, everywhere you see question mark, clicking on it, you will get a short explanation. What does it mean? And here you see, first of all, how to measure it. Yeah, we have like a special tool to measure it. In here are also some of our experience values for different roof coverings. Yeah, membrane, bitumen, substrate, gravel, concrete, and so on. E plates, yeah, concrete blocks. Today we will talk about it. So it's not like you can freely select one of them or put here some values just to get the system verified. So it's like it's a very important value, and it just has to be exact. That has to be correct one. Yeah. So, for example, for membrane we have 0.5 value, yeah, and let us calculate this. Maybe probably first in ballast. Yeah. So we have now 0.5. We deselect anchors. So here's our values for 0.5 friction coefficient. Here it's for 14,000 kilos. Yeah. And if we change the friction coefficient to 0.7, for example, you will see that here we have already much less ballast. Yeah. And as I said, if we calculate our anchors are coming from ballast calculation. So we just calculate how many ballast is used to prevent sliding and how many ballast is used to prevent lifting. Yeah. And in this way, we also calculate our number of anchors. Let us check if here will be different number of anchors. So calculating with 0.7 friction coefficient, we have 84 anchors. Let us change it again to 0.5. Results. And now we have 10 anchors less. It's because we need less anchors to prevent sliding and to prevent lifting of the system.
Thanks, Lodo, for that. And I think another point we could add to that as well, though, is you cannot just change the friction coefficient within the software. It's the first three parts of the base software where you go project, loads, and roof. This is effectively building up your simulation, and this should be as accurate as possible. So where we have played around with it today, you should just get that information from the beginning, put it into the software, and then you can move forward. Excuse me. We had another question about mineral insulation, and we have sort of two topics that come on to that. One is, oh, sorry, I thought we could probably just talk about a little bit more, but one is the compression. So often it's quite soft, and there is a concern that if you weigh too much material on top of it, it will compress over time. There's usually a 2% and a 10% compression factor that is specified by the roofing manufacturers. With the compression part of things, anchors don't come into it as such. So the anchors are usually screwed into what is underneath the insulation, and they are providing sideways movement and uplift movement. With the compression, it's actually the downward force. So underneath the mats, this is all of the force that's on top is being converted into a pressure onto these small feet. And one way to increase that pressure is to decrease that pressure is to expand the area, right? So the force over area is equal to your pressure. So you can add more of the mats. We will be also releasing some new tools and products over the next couple of weeks that allows you to increase the surface area of the contact point. So then spreads the force over a greater distance and reduces the pressure. In terms of sort of the other side of things, though, it's also does have the possibility of this sideways movement. Well, movement's probably the wrong word. The sideways force that's going to be applied to the anchors. This can also impact the roofing insulation in some ways, and we don't necessarily say you can do this or you have to do this for the different anchors, but we do know that many of the roofing insulating companies have their specific requirements and their specific regulations about how the anchors need to be fixed. Some of them have their own anchors. So, for example, Seeker is a roofing company more than an anchor company, whereas CB Lundberg specializes in roof anchors. Seeker is doing both. So specific companies may already have products that they are allowed to use or that they are recommending to use on their roof. And if we can then fix to those products, then that's not so much of an issue. I think goes into that one. I see there's a few other questions as well, or are they things that we can add here? The yeah, so a follow-up question about the and so maybe we'll just explain it a little bit again. So we have a building that has a friction coefficient, and from that we determine what is needed to secure it. So whether that be ballast or anchors, there is a force sliding down the roof. Determining that force and the forces required on the fixations will determine the number of anchors. So yes, we might have a fixed system, but how do we know it's fixed? If that makes sense. We can say this thing, if it has 4 anchors, it might slide down, but if it has 8 anchors, it might not slide down. This is a point that comes after the question of will it slide down in the first place. So the friction coefficient is something that you need to put in regardless of the roof. Probably one point on that, or one thing where it differs a little bit, is for gravel roofs and green roofs, because gravel roofs and substrate roofs often have, what would you call them, little walls built into them to stop the gravel moving down the roof. And so the friction coefficient for gravel roofs and substrate roofs is a little bit different to the membrane roofs. But in situations like that, because you have 5 to 10 centimeters of gravel or substrate, the anchors often aren't a solution that's possible for those roofs. Anything else to add on that, Vlado, or are there any other questions that had come up?
Yeah, so maybe I can also add that in base you will also see this friction coefficient values for also for gravel and substrate, and there are also different Klaus, can we share again maybe? This is screen, yeah, you can see it here. If you use PE plates, so it means you will install the systems not on the S, but you will install it on bigger plates, stick plates, which are embedded in gravel, so you will get such much higher friction coefficient. That means that probably it's very high, so probably no sliding at all. Yeah, and if you use concrete blocks, so that means that if you will install your classic system, dome system, not on mattes but on stones, yeah, you will also get much higher friction coefficient. But all these possible situations are also like explained here, so you can always open it and see what are our experience values for all possible our solutions.
Vlado, maybe could you just jump back to the results page and go design user feature, user input, sorry. So we just had a question about the there's no input fields in base for the vertical and horizontal forces accepted by the user defined. So when you do put in user defined, you will get a preset value. However, you can then change that. So what is it, 1.6? So if you put it as something else, it will jump back to a certain point. If you have a high load, sorry, if your anchor is really strong, you might have something that's, as Vlado just put in 2, some of them 3.6, some of them go up to 5. However, it is also fixed to our component. And so the limiting factor is often the FixPro Set, so our component. And so if you put in a value more than what our product can handle, it will jump back to the value that that is limited by this. Yeah.
Can we share again, Klaus? Because here, for example, yeah, this is our maximal value for our climber, but here, for example, you can usually put a higher value or not. Let me check on this one. How jumping back all the time. Because you have to feel this one. Yeah, and we have again a question regarding Solomon AB set and Solomon usual one. So as I said, this one is set, how we call it in German. It's like just special German certification. So if you are not from Germany, install it. So select normal Solomon, and if you are from Germany, then you will have to use this one because it has like a special certificate for installation in Germany.
We also had a question about the east-west system for maybe a roof over 10 degrees. So this is more of a choice question for an energy production perspective. So there are 2 parts of obviously putting PV on a roof. One is how much energy you want to produce, and the other part is how easy is it going to be to put the PV on the roof. And so the sort of industry, the way it's been built up, is that for flat roofs, you would like to increase the inclination in one direction, whether it be south or in an east-west direction. And this gives you a bit of flexibility to determine how much energy you're looking to produce, depending on the time of day and your own needs. However, and with that, you can just place it on the roof, generally speaking. So you can just ballast it down or with the anchors that we've shown today. With pitched roofs, though, the inclination is then a little bit higher and the roof structure is very different. So you are limited in many cases as to where you can put the modules and how you can put the modules. So while practically it is possible to put modules at an inclination for a higher roof pitch, it's often not so practical from a construction point of view. If you do have any questions or situations where you would like to do that, you can send us an email. So our technical sales team, which we're part of, and we have a whole team as well, is it's on the screen now, service at k2-systems.de. We'll be happy to take a look at it.
Yeah.
Yeah.
So maybe I can add to this question that surely you can install east-west system on your roof with 10 degree. East-west system is more aerodynamic than our roof parallel system as Dome Zero, for example. Yeah. So probably you will need less anchors for it. But for example, installing a roof parallel solution like our single rail AFP I showed you previously, this one, yeah, you will need much more anchors because it's not so aerodynamic as east-west solution. But it's like up to you. Yeah, because surely if you install models roof parallel, you will get much more models on your roof because you have no row spacing between the models, between the peaks and between the models. So like advantages is and disadvantages of each system. So it's decision is up to you.
Oh, super. All right. Well, we are our questions, which is a good sign. Hopefully, we've been able to provide you with some of the information you're looking for. Thank you everyone for joining today. If you have any questions, obviously email that thing before us. With that email before us, we've just put up a poll as well, which helps us know how you felt today went and help us improve for the future. Speaking of the future, we have no webinar next week actually, or the week after, because we are leading up into Intersolar in Munich. If you would like to come to Intersolar and you don't have a ticket, we can also actually provide you with a ticket. Unfortunately, no accommodation or flights, but you can meet us. And on the Wednesday, we will be having a booth party, which last year was very enjoyable. I think this year will also be quite enjoyable as well. Klaus, can we put that link in the? We'll put that in. So on the website, you can just register, and you can get a day ticket, at least one day ticket, I believe. If you can't make it to Intersolar but are still interested in some of the things we will be presenting the week after Intersolar, so I think it'll be the 14th of May, we'll do a bit of a webinar or a recap on everything that we've presented, so all of the new topics from K2, which should be quite exciting. And I think that's probably about it. Thanks everyone for joining today. Lano, thanks for your help. It's good to be back. We're doing it with you. Been away for a few weeks, which is good. And Klaus, who makes it all happen in the background. Until next time,
You,
farewell.
see you. Bye bye.